purpose of this video is to walk you through getting started and understanding the code sample associated with my blog post, Manual Failover of Azure File Storage. The goal of this sample is to address the following scenario. I have a deployment architecture in Azure which requires web servers, but can be anything, to communicate with a remote file share. I want to use Azure File Storage. I also need to maintain a geographically redundant environment in another Azure region. I'm required to demonstrate end-to-end execution of my disaster recovery plan. And most importantly, the end result must show all pieces of my deployment architecture running in the other region. As I point out in the blog post, your first reaction might be to use geo-redundant storage. As of today, geo-redundant storage doesn't give you the fine-grained control to force Azure storage to switch to using the replica in the other region and prove that. Therefore, it won't meet the requirements. However, if you're okay with trusting that geo-redundant storage will fail over in the event of a disaster, as documented, and aren't required to prove it, then using geo-redundant storage is probably the best answer for you. The sample I'll walk you through requires additional effort on your part to be able to demonstrate after failover using a secondary in another region. You might also consider read-access geo-redundant storage, and in concept that would work. You could use that read-only secondary as the source for your disaster recovery, make a copy of it using a tool like AZ copy, and copy it into another storage account, and then point your application to that storage account. However, at the time of this post and recording, Azure File Storage doesn't support read access geo-redundant storage. Said another way, you don't have a way to get at that readable secondary when you're using Azure File Storage. So to use this sample I put together, come over here to GitHub. You can either clone or download it. What I've done is I've just downloaded the zip file and I've unzipped it locally and I've opened it up in Visual Studio. As I explained, basically what this sample does is it uses the Microsoft Azure Storage Data Movement Library and the Microsoft Azure Storage SDK for .NET to demonstrate how to keep a secondary Azure File Storage share in sync with a primary share. It basically copies everything in the source file share to the destination file share. It'll only copy files if the source file is newer than the destination file. And then it will compare the destination share to the source share and delete files and folders in the destination which have been deleted in the source. As I note here, this sample runs in a console application, but can be repurposed to run in a number of hosts, such as an IaaS VM, a web job, a worker role, Azure Automation, etc. And you can choose to run it scheduled or continuously based on your requirements. So the first time you open the code, you're going to notice that I have an app config, and that app config has a source connection string, the source share, a destination connection string, and a destination share. And I'm using transforms to have a debug and release config. Now what you'll notice is that the app debug config isn't actually stored in GitHub. And the reason I do that is so that locally I can have my settings and not have them stored in the repo. So let's go ahead and create this file. And the easiest way is just to copy this and rename it. Now if I go into Visual Studio and open this file, I need to provide some values. So I've already created two storage accounts, one in the East US and one in North Central US. You'll notice that both of them are locally redundant storage because I'm going to be doing the work of keeping the secondary in sync with the primary. And each storage account has a file share, which I've just named share. And for the remainder of the walkthrough, I'll be using Azure Storage Explorer to upload and demonstrate the copying and deleting of files and folders. So to save time in the walkthrough, I'm not going to go through how to create storage account connection strings for the .NET storage libraries. But basically, we just need to come in here and provide share values. So we know that the shares are called share. So I'll update those. And I'll pause here to insert my source and destination connection strings. All right, so I've closed my config file so you don't see my keys. And I've opened up program.cs and notice that we've got some errors, but if I build, of course, the NuGet packages that I'm using will be restored, and the build will succeed. All right, so before we walk through the code, let's just see how this works. All right, so notice that I have nothing in the primary share, and I have nothing in the secondary share. So I'm going to go ahead and upload a file. Now I want to copy that file to the secondary share. Let's go over to Visual Studio. Let's start this without debugging. And notice that it copied the file to the secondary. So if I refresh this, there's the file. Now if I edit this, and go over to the share and upload it again, notice I'm in the primary again. And I control F5 again, it copies it again. Now this time I haven't changed the file. I'm going to run the app again. Notice it doesn't copy anything. Now if I upload a folder, okay, so I cut out the time in the video it took to upload these 497 files. It took a couple minutes, but what you'll see is when I actually run it over here and copy it from one file share to another, it's actually pretty fast. So this copy happened much faster than the time it took to upload. And I'll explain a little bit of this why when we walk through the code. And this, of course, would be even faster if the code itself was running inside of Azure. Right now it's just running on my local desktop. All right, so now if I go over here and well, first of all, let's just verify that those files are there now in the secondary, and they are. If I go over here to the primary and I delete and I run this again, it takes a little while because it's comparing the source of the primary, but eventually it figures out that it just needs to delete the text file that's no longer in the primary from the secondary. And similarly, if I go over here, and so we can go to the share, the secondary share, we see that it's gone. Similarly, I can delete the directory from the primary. Again, this will take a little time to delete using Azure Storage Explorer because all the commands to delete are coming from my client. If I come back to the application and I run it again, it's deleted all the files in the secondary because all those files were deleted in the primary, and it's also deleted the directories. And we can validate that by coming over to the share and recognizing it's empty as well. Let's take a look at the code real quick. So the first thing we're doing is setting some values based on guidance from the Azure Storage Data Movement Library. And I've provided links to those recommendations there. Next, we're just doing some pretty standard Azure Storage Library coding. Then I just simply call two methods: copy newer source files to destination, and then delete destination files and directories no longer in source. So to copy the files, this uses the data movement library. We create something called a transfer context, And ultimately that transfer context will be passed off to this call called copy directory async. And so I've wired up some event handlers in the transfer context for file failed. And what you'll notice is I'm just dropping these things to the console, but you could obviously log, do whatever you want here. Anytime a file copy fails, this event handler will be fired and you can get access to the args and do what you want. Similarly, if a file is skipped, in this case I'm not doing anything because I expect things to be skipped, but I just wanted to demonstrate the file skipped event. And then file transferred. And in this case, again, I'm just writing to the console that the file was transferred and the actual URL of the destination. Now, by default, the data movement library will not overwrite files in the destination if they already exist. But it has this overwrite callback that you can wire up. And in my case, what I'm doing is I'm just using the source and destination. I have to call back to get the actual attributes because the source and destination are just string values with the full URL to the actual file. So we get the attributes, and then we just compare last modified values. And if the source is greater, then we want to overwrite. And if not, we just return false, which means we skip overwriting the file. Before we call the copy directory async method, we want to set up a copy directions options to tell it to copy recursively. We pass it the source dir, the destination dir. We specify that this is a service copy, which means that the file doesn't get downloaded from the source to the calling app and then uploaded to the destination. It does a service side copy, which is what makes it fast. We pass those copy direction options and then that transfer context. We just wait for it to complete and then we return the results. In this case, the caller doesn't actually do anything with the results, but you could certainly do something with the results. All right, so now we've copied all the files. Now we want to go through and delete. We're essentially listing the files and directories in the destination, and this will give us everything in the root. And then for each of them, I'm going to check if it's a file. If it is a file, I'm going to see if the file exists in the source. And if it does, we do nothing. If it doesn't exist in the source, then we delete it from the destination. And then I just, again, dump to the console. If it's not a file, then I check to see if it's a directory. If it is a directory, then we're recursively calling this method to do the same thing in the subdirectory. And then finally, after all that's done, if a given directory has no files in it, then we want to delete it. And then again, I log it to the console. And of course, this code is a sample. It's not intended to be production ready. There's certainly opportunities to go through and optimize the code a bit, add good exception handling, etc. But hopefully this walkthrough gives you a sense of how to get started and how the code works.